Suit at 1 atmosphere in a vacuum. This is uncommon because we wouldn't run the suit at 14.7 psi or 1 atmosphere. We wouldn't need to. But this is what the numbers would be. I would see 14.7 psi gauge, or over ambient, relative, because between the inside and the outside of the suit is 14.7 psi or 1 atmosphere. Pretty obvious right there. Here's a suit in my bedroom, you know, in the shack, in the workshop. Again, same pressure on the inside and outside equals 0 differential pressure. Now over ambient, but to simulate at 10 psi, so maximum suit pressure for stress loading. Again, 14.7 psi in the house. We run the suit at 24.7 psi absolute to simulate, to get functionally 10 psi differential pressure. And you'll see I can do the same thing. If I reduce the outside pressure to a vacuum and I put the suit to 10 psi gauge, I get also an absolute. So this is me running the suit in a vacuum chamber, like NASA would do at rupture, which is on 10 psi for them. Here it is, the suit at 3.6 psi over ambient, but in a vacuum. This is normally what it would be like if I was in orbit, for example. You run the suit at 3.6 psi or quarter atmosphere, and that's what you get inside and outside. Again, hopefully pretty obvious. Now I'm going to show you what it's like if I wore the suit over ambient running. So running pressure. Remember, we only run the suit at 3.6 psi. So here it is. Here it is here in a vacuum on the outside. Okay, so here it is at 3.6 psi over ambient. This is the analog sim pressure. So 14.7 psi on the outside, 18.3 on the inside equals 3.6 differential. Once again, this is a good way of showing how we can run the suit at the same stiffness as a suit in a vacuum without having to be in a vacuum. We just run at a higher pressure. That's it.